Hi you guys and welcome to today's lesson. Today we're going to talk about 45 degree, 45 degree, 90 degree triangles. But before we get to that, let's do a little warm up when working with radicals. Remember that when you are multiplying radicals, anything underneath the radical gets multiplied together, and anything outside the radical gets multiplied together. So we, as always, assume that 1 out in front, so 2 times 1 is 2, and then underneath 3 times 5 is 15. So I get 2 root 15. And we look at 15, and 15 cannot be simplified. There's no perfect square that divides into 15. So we try root 6 times root 2, and we get root 12. When we look at root 12 is 4 times 3. But the square root of 4 is 2. So a 2 comes out in front, and we've got this root 3 left over. And that's our final answer for that one. So we tack a root 3 out in front, just like root 6 times root 2. We've got 3 root 6 times root 2, so we've got 3 root 12. And again, 12 is 4 times 3. And the square root of 4 is 2, so 2 comes out, but there's already a 3 out there. So now I end up with 3 times the 2 that comes out, and then root 3, and 3 times 2 is obviously 6, so 6 root 3. And then the important one for this lesson is 3 over root 2. We talked about rationalizing the denominator, so we took 3 over root 2, and you multiply the top and the bottom by root 2. Now remember, root 2 over root 2 is really in essence 1, so we're not changing anything, we're just changing the look of that 1. So on top I get 3 times root 2, which is 3 root 2. On the bottom we get root 2 times root 2. Now here's the long way. That gives us root 4, but what is the square root of 4? 2. What we're hoping is that throughout this unit you start picking up on 3 over root 2 is 3 root 2 over 2. So if I had 5 over root 2, we can make the leap and just go 5 root 2 over 2 without having to do all of that algebra right there. Okay, so let's get to the 45, 45, 90 triangles. First of all, it's isosceles because we've got two congruent angles, that one and that one. And it says check for tick marks and angle measures. So for the angle measures, sometimes they're going to give us, let me do this real quickly, they're going to give us the actual angle measures. So now if I put 45 degrees here, we remember the angles of a triangle add up to 180. So 180 minus 90 minus 45 is 45. Well, knowing our triangles from before, we know if we've got two congruent triangles right there, it's an isosceles triangle. In this case, obviously, it's a right isosceles triangle. Sometimes they're going to give us the tick mark. They're going to say that's congruent to that, or they're going to use 2 tick marks or 3 tick marks, whatever it is. So showing that this side is congruent to this side. So if this is 6, I know that's 6. Okay, let's continue with that then. In the general sides of a 45, 45, 90 right triangle, this side is x, which means this side is x because we know that these are congruent. And then this side, the hypotenuse, which we will label with an H in a circle, is x root 2. So we're giving you a shortcut how to find the side lengths of that triangle. So applying that, looking at this is x and that's x, those are the same thing, and then this is x root 2. I take whatever I have here and place it in front of root 2. We try it on this one. So there's my right angle. There are my congruent tick marks. So I know this is 45, 45, 90. So if this is 6, we know that this is 6. So there's the x, here's the 6, there's the 6. And then it had x root 2, so this becomes 6 root 2. Let me show you a little side step here. We go back to the Pythagorean theorem, we have 6 squared plus 6 squared is equal to my hypotenuse squared. 6 squared is 36, 6 squared again is 36, and 36 plus 36 is 72, and then we square root both sides, and the square root of 72 simplifies to 6 root 2. So what we're doing again is we're saving you all this work with little memorization on your part to know that this is 6, this is 6, this is my leg times root 2, so 6 root 2. So let's try that again. And notice now I've got 45-degree angle, which means so is this one down here. So this is 8, this is 8, this is 8 root 2. And you can do the Pythagorean theorem and still get that 8 root 2 right there. Look at this one right here. That's 5. This is 5. This is 5 root 2. Now it's important to pay attention to these tick marks because we're going to get to another type of triangle in a different lesson, or you will see another type of triangle that's 30, 60, 90, and it's not going to be the same type of setup. So you really got to pay attention to these tick marks, knowing that this is 45, 45, 90, as opposed to something else. So again, 5, 5, 5 root 2. Now this one, I know that my legs are congruent here because my angles are marked congruent, so 45, 45, 90. So if this is 7 root 2, this is 7 root 2. Now this is different from these up here and over here because now I've got a radical attached to my leg as opposed to a plain old integer here. So I still take the 6, the 6, the 6 times root 2. I take 7 root 2 times 7 root 2. I still take my leg and I multiply it by root 2. So there's the 7 root 2, 7 root 2, 7 root 2 times root 2. But root 2 times root 2 is root 4, but the square root of 4 is 2, so now I've got 7 times 2, which gives us 14 for that final length right there. Try to make that leap. Root 2 times root 2 we know is 2, and then 2 times 7 is 14. That's a special situation that you might see. Now, going backward, I gave you the hypotenuse this time. So again, our general sides are x, x, and x root 2. Well, if I want to solve for x here, I'll divide both sides by root 2. Well, that's nice because these root 2's cancel, and so do these. So what does x equal? 6. So I know this side length is 6, and this side length is 6. I'm just, so to say, stealing that 6 out in front of the root 2 when I go backward. So there's my 17 root 2 for my hypotenuse. So I take the 17, and it goes here and there. So again, pointing out here are my side lengths, general side lengths, x, x, x root 2. I gave you the hypotenuse again, so we work backward. It does have the root 2 attached to it, so now I take the 7, and here, and you'll notice x, x, 7, 7, and then x root 2, so 7 root 2. If you ever get stuck, you can definitely, if you have two sides, you can use the Pythagorean theorem to figure out that third side. Now, actually, look at the difference between these two. This is 7 root 2. This is 7. There is no root 2 attached to it. Now remember, this is my general side x, this is my general side x, and this is my general side x root 2. So I take that 7 and I set it equal to that x root 2 because that's my general side length for my 45, 45, 90. Well, to get x, which is what I want down here, I divide both sides by root 2, which is why we did the radical review problem up above. Well, these cancel, and I get x is equal to 7 over root 2. But I can't leave it as 7 over root 2. I've got to multiply the top and the bottom by root 2. So on top I get 7 times root 2, and then root 2 times root 2, make that jump, is just 2. What I'd really like to show you, if you can make the jump, is this. If you have your hypotenuse with no root 2 attached to it for the 45, 45, 90, all you attach to it is a root 2 over 2. 7 root 2 over 2. I'm helping you skip all this algebra. A little memorization on your part can go a long way for that one. So let's try this. Hey, my hypotenuse doesn't have the root 2 attached to it, so I attach a root 2 over 2 to it. Now, in this case, though, 8 over 2 simplifies to 4 root 2. So there's my simplification, and remember that when I solve for x, this is my side length here and here. 8's my hypotenuse, so my side lengths, my leg lengths, are 4 root 2 here and 4 root 2 there. So let's try another one of those. We'll say that this is 12. Okay, hey, it's missing the root 2, so we attach root 2 over 2 to it. But 12 divided by 2 is 6 root 2, so 6 root 2 is this side length, and obviously if that's 6 root 2, that one is also 6 root 2. So see if you can make that jump when working with those figures. Here are a couple more to check. Oops, it went too far. Here are a couple more to check. So I've got my hypotenuse. It doesn't have the root 2 attached to it, so I attach root 2 over 2 to get my leg length. But 9 over 2 doesn't reduce, so 9 root 2 over 2 is my leg length, which means this is also 9 root 2 over 2. And then you can try that one as well. I've got my hypotenuse. It's a 45, 45, 90. Again, paying attention to the tick marks. So then I attach a hypotenuse without root 2, so I attach root 2 over 2 to that integer for my leg length. But 12 divided by 2, 6 root 2, and 6 root 2. Let's try one more of those. So this is 15. Oops. There are my tick marks showing its isosceles 45, 45, 90. Hey, my hypotenuse is missing the root 2, so I attach a root 2 over 2 to it for a leg length. 15 root 2 over 2, and obviously 15 over 2 does not simplify, so you leave it as 15 root 2 over 2.